Hi all. So this is the first lecture on the topic testing of hypotheses. We already learned that the subject statistical inference is generally classified into two main sections, such as estimation of parameters and testing of hypotheses. And we have already completed a full course on estimation of parameters, in which we focused on finding best estimates for the population parameters based on a random sample from those populations. In this paper, that means testing of hypothesis, what we are going to do is that we are maybe we have a population having a number of parameters, and in this paper we need to test the effectiveness or the validity of some statements regarding this population parameters. So we need to test these statements statistically. Clear? So throughout this paper we try to build certain procedures for to carry out these type of problems. So let us start. So first of all, what is a hypothesis test? So it is nothing but a statistical procedure that allows you to use a sample to draw conclusions about the entire population. So more specifically, a hypothesis test evaluates two mutually exclusive statements about the population and determines which statement the data supports. These two mutually exclusive statements, which we call as hypothesis. Clear? These two statements are the hypothesis that the procedure is going to test. Okay, so we call the one as the null hypothesis and the other as the alternative hypothesis. We will discuss these on coming slides. Okay. So before going to the details, let me recall the terms population parameters and sample statistics. A population parameter is nothing but the one which describes the characteristics of the entire population. For example, population mean, population median, etc., etc. And a statistic is nothing but a function of the sample values or a characteristic of a sample. So if we collect a sample and calculate its mean and standard deviation, I mean sample mean and sample standard deviation, etc., those are actually sample statistics. Clear? So in this estimation of parameters paper, we find suitable sample statistics to estimate certain the corresponding population parameters. So in this testing of hypothesis paper, we use these estimates to build certain test procedures for taking decisions on the specified hypothesis. Okay, so inferential statistics allows you to use sample statistics to make conclusions about a population. Okay, so inferential statistic is basically making decisions making decisions on population parameters based on the sample we have. Okay, so actually this testing of hypothesis we classified broadly into two, that is parametric test and non-parametric test. So parametric test, in parametric test we assume that the probability distribution, okay, the probability distribution of the population is known. And in non-parametric test we don't have any assumption about the population distribution. Clear? So we will discuss all these terms in detail. Okay, so let's go to the next slide. That means so I already told that in this testing of hypothesis paper, we are going to make a procedure to test two hypotheses. So the first one we call it as null hypothesis, and the other one we call it as the alternative hypothesis. The null hypothesis is the one of the two mutually exclusive theories about the population properties. Typically, the null hypothesis states that there is no effect. Clear? We kept this null hypothesis as a neutral statement. Clear? So for example, in many research problems the researcher may want to test the effectiveness of certain treatment. So the null hypothesis states that particular treatment has no effect. Clear? And our interest, we will keep our interest in the alternative hypothesis. Clear? The alternative hypothesis, typically the alternative hypothesis states that a population parameter does not equal to the null hypothesis value, means there exists a non-zero effect. That means there exists an effect of that particular treatment. Clear? So our interest, we will keep our interest in the alternative hypothesis. Clear? That means what we are expecting is rejecting the null hypothesis. Clear? Because our interest is in the null hypothesis. So if your sample contains sufficient evidence, you can reject the null and favor the alternative hypothesis. For example, if you are comparing the means of two groups, the alternative hypothesis is often states that the difference between the two means does not equal to 0. Clear? So we already I already said that we take decisions based on a sample, decisions on the population parameters based on a sample from the population. So surely there exist errors. That means these estimates may not be equal to the corresponding population parameters. So there must exist a sampling error, and the correspondingly there must exist errors in the decisions that we had that we were taken. Okay. So we know this null hypothesis and alternative hypothesis. So statisticians define two types of errors in hypothesis testing. Creatively, they call it as type 1 and type 2 errors. So the type 1 error is nothing but we reject the null hypothesis when it is actually true, and type 2 error is nothing but we fail to reject the null hypothesis when it is actually false. Clear? So to understand this more easily, consider a fire alarm system. So what we are expecting is that the alarm rings when there is fire and does not ring in the absence of fire. Clear? So however, if the alarm rings when there is no fire, which is nothing but a false positive situation. Clear? So we call it as type 1 error statistically. Clear? So conversely, if the fire alarm fails to ring when there is a fire, this is nothing but a false negative type situation, and we can call it as a type 2 error statistically. Clear? So these concepts are very simple, and the next term is a significance level, and we will get into more details on these topics later. So what do you mean by significance level? So the significance level defines how strong the sample evidence must be to conclude an effect exists in the population. So this is actually a prefixed quantity. Clear? If our evidence is we are prefixing the limit. Clear? That we need to have to take a decision on this null hypothesis. Clear? So moreover, this is defined as a probability of rejecting a true null hypothesis. That means probability of type 1 error. that is nothing but the significance level. For instance, a significance level of 0.05 signifies a 5% risk of deciding that an effect exists when it does not exist. Clear? That means it is nothing but rejecting a true null hypothesis. Clear? Simply a probability of type 1 error. Clear? That is a significance level, and this is a prefixed quantity. So before the testing procedure, we will fix this quantity. Clear? So usually 0.05 or 0.1, and the p-value is nothing but it represents, otherwise it tells us how strongly your sample data contradicts the null hypothesis. That means lower the p-values represents stronger evidence against null, and we reject the null hypothesis when these p-values are less than the prefixed significance level, and we fail to reject the null hypothesis if this p-value is greater than the prefixed significance level. We will also get into more details on p-values on the coming lectures. So in this lecture, what I am planning to give is a brief introduction to this paper and various procedures for testing and various methods we will discuss further. Okay, thank you.